Hey everyone, welcome back to how to build a layout from start to finish here on TrainWorldTV. Now we're really moving along and we're ready to talk about circuit breakers. So with that said, let me show you exactly what you need to look for in a circuit breaker and what they do for a layout that's district out, so you can maybe save some very expensive equipment. Let's go ahead and get started. So the circuit breakers we're going to be using on our layout are the NCE EB1 circuit breakers. You can find these on TrainWorld's website and pre-order them. They may even be in stock depending on when you actually see this video. Now the purpose of the EB1 circuit breaker is to protect both your equipment, such as locomotives, rolling stock, can actually have problems in detrimental cases, and your NCE system or whatever DCC system you pick. And you want to make sure that everything plays with each other, but usually circuit breakers they have one purpose, and it's not going to usually have different adaptation issues, so you should be able to use any type of circuit breaker you want with most systems you want. Now, the systems may not require a circuit breaker depending on what you're doing, but the larger you have a layout, the more locomotives you're running, you may want that circuit breaker. We talked about districts. The circuit breakers are one per district. So as you can see on the diagram on your screen right about now, the 4 circuit breakers I'm using for my double main line are going to 4 different districts. I separate the districts with a plastic insulated rail joiner, and if something goes wrong on that district, the circuit breaker will trigger and it will stop power on that district, and it's very simple to diagnose at that time. Let me show you a little visual of what the circuit breaker looks like all lit up. Now here is a circuit breaker installed under my layout. You see the indicator light. You can actually run LED output lights from this circuit breaker to the actual upside of your layout, so you know what the status is. But if this triggers, there's a reset button, and that is the NCE circuit breaker all hooked up. Again, I will put the wiring diagram back on so you can see how the wiring for these work. Now, as you can see here, we have plastic insulated rail joiners. This keeps this district separate from this district. Camera doesn't want to play along here. This district separate from this district. What that's going to do is have that circuit breaker handling just that district. So if we have a short here, the circuit breaker triggers, saving the locomotive or saving the system from overheating or problems. And then I can go around looking at my indications and see which district is no longer powered because the circuit breaker tripped, and then go to that district to find out what's going on. Is my locomotive shorting out because it's got brass contacts that are hitting both rails and causing a bridge? Is there a piece of rolling stock having a problem, or is there just a wire laying across the layout in that district? Alright, as you can see on our paper here, this is the layout of 4 different districts, 2 different colored wires, and you're always going to keep those wires separate per side of the rail. So as you can see, the yellow wire goes from the DCC system to our first split off there, and then it goes to circuit breaker 1. And circuit breaker 1 goes to district 1, where the feeders, the 2 different color feeders, the yellow and the green, I believe, colorblind, I think that's what that is, are powering each side of the rail. And as long as you keep a color code of which power rail is separate from each other power rail, and you keep that rail the same color all the way around, you'll be fine and have no issues with wiring DCC, let alone these circuit breakers. All these circuit breakers are doing are essentially passing through, but where on my original layout there's just a loop of a bus with feeders going all the way around, this requires me to wire a little different. And that means I'm going to circuit breaker 1 and district 1. Then I'm rewiring the bus again from the DCC hub here to all the way back around to district 2. and then doing it again for District 3 and again for District 4. Now, depending on where your DCC system is, you may want to split and send two, wires going one way and two wires going the other way for your bus lines for these circuit breakers to pass through. Another point I want to make is these circuit breakers will not take a wire any bigger than 12 gauge, so you don't want to go any bigger than that on the EB1. I barely fit the 12 gauge bus wire in the EB1 circuit breaker and back out. So hopefully that gives you a good idea of how circuit breakers work. You can adjust the trip current for these circuit breakers from 1.5 to 8 amps. And it also talks about how easy it is to hook up these using screw terminals and no soldering. And that's why I like the terminal joiner, because you can hook everything up using screw terminals with no soldering. Now you may want to clamp on these little pitchfork ends to the wires. Somebody had suggested that, but I prefer just to feed the wire in there, feed it left to right, and as the screw turns clockwise, it's catching the wire and putting it in the terminal joiner. Well, I hope you have a better understanding of circuit breakers and whether you want to apply them to your layout or not. But it is very important that I show you these circuit breakers, because I want to make sure that because of the size of the layout I'm doing here, a larger layout may require things like districts and circuit breakers. So with that said, thanks for watching, and we'll see you next time right here on TrainWorld TV. Take care.